Welcome to KEP Curriculum. Let's begin by discussing how to subtract integers.
All right, let's go ahead and hit pause for this section so that you can write as much of this information down as you need to. The only thing that I wanted to point out here is what we need to remember for our integers. Before we get to subtracting integers, it's very important that you remember your positives and negative signs, guys. So if you're subtracting integers on the number line, there are 3 steps that we have come up with. One is to change the subtraction problem to the addition problem, and we like to use KCF. And then we're going to plot that on the number line and then use that second number to move. So let's look at how that's going to be done. In this section, we are subtracting negative integers on the number line. So remember, the first step is to change that subtraction problem to an addition problem. Now, the way that you change that subtraction problem to an addition problem, we like to use keep, change, flip. Now, it's really not flipping as in what we're doing with the fractions. We're just flipping that sign from a negative sign to a positive sign. So step number 1, change subtraction problem to addition problem by keeping that first integer the same, changing subtraction to addition, and then flipping that second integer from whatever sign it is to the opposite. So we're going to go from changing a negative to a positive and a positive to a negative. Now the second step is we want to plot that first integer, that first value. So looking at your number line, that first number is what you're going to highlight. The second integer or the second value is how we're going to move. So we're moving and in a position, in a way of talking about absolute value. We're moving a specific distance. So if we're moving in the negative direction, we need to remember that we are moving to the left. And if we are moving in the positive direction, we need to remember that we're moving to the right. So step number 3 is to move the absolute value of your second value or of your second integer. And if you flip it and it becomes negative, you're moving to the left. If you flip it and it becomes positive, you're moving to the right. All right, let's try some problems. This first let's do this is 10 minus negative 7. So based on step number 1, the first thing that we are going to do is to keep, change, flip. And I like to write it in. Keep goes above the 10, the C for change goes above the minus sign, and the flip goes above the negative 7. So that positive 10, we're going to keep it. We're going to change that subtraction symbol to an addition symbol, and then we're going to flip that negative 7 to a positive 7. So once we've done our keep, change, flip, our second step is to plot that first value. And you see I've highlighted it here in green. The third step is to move the absolute value of that positive 7. Because it's positive, we're moving to the right, and that will give us 10 plus 7 is a value of 17. Now I want you to hit pause here and try and see if you can do the check for understanding by yourself. I know you got this. All right, welcome back. Let's keep, change, flip this problem. We're going to keep the 9, change the subtraction to an addition, and then flip that negative 3 to a positive 3. So the way we put that on our number line is that first value gets highlighted, and we're going to highlight 9 on our number line. And then we are going to move 3 spaces in the positive direction. So 9 plus 3 is 12. And you can easily see that on our number line. Let's jump down and let's start with some that start with a negative. So here we have a negative 6 minus a negative 4. we still go through the same exact process and we keep change flip. So we are going to keep that -6, change that subtraction to an addition, and then flip that -4 to a +4. So the first thing we do is to plot that first value. So -6, we're going to find that on the number line. And then we're going to move 4 spaces in the positive direction away from that -6. So when you count that out here, I'm just counting it slowly, 1, 2, 3, and 4, and you see it stops there at -2. So it depends on who is larger. Remember when we were adding before, if we're adding a positive and a negative and we have more negatives, that means our answer will still be negative. If we're adding a positive and a negative and our positive is larger, then our answer will be positive, okay? So go ahead and hit that pause button and let's see if you are ready for this check for understanding. All right. Here we are back, guys. Let's keep change flip this problem. So we're going to keep the -21. We are going to change this minus sign to a plus sign, and we're going to flip that -15 to a +15. So step number 2 is to plot that -21 on our number line, and then we are going to move 15 spaces in the positive direction. Now you have to pay attention to the scale on your graph. I like to switch them up all of the time. You see the scale here moves by 5s. So in order to move 15 spaces, we're essentially moving over 3 to land us at -6. If this made perfect sense to you and you feel like you can subtract negative integers on the number line, go ahead and check that box to say that you can. Happy learning! All right, now let's practice subtracting positive and negative integers using models this time. All right, the way that we're going to subtract these using models is we can use keep change flip again to change our subtraction problem to an addition problem. It's so much easier when we have an addition problem that we're going to deal with. So go ahead and jot this down. Step number 1 for the how to is to change your subtraction problem to an addition problem using keep change flip, or our modified version of keep change flip. Step number 2, we are going to model what we see. So if we see 4 and it's a positive number, we're going to show 4 as the model for positives. If we see 6 as a positive number, we're going to model 6 as that positive number. And then remember, we're just comparing who has most. Do I have more negatives? Do I have more positives? Do I only have negatives or positives? And then we work it from there. So let's go ahead and do this one. We have a subtraction problem. So the first thing we do is keep change flip. We're going to keep that +2, change that subtraction to an addition, and flip that +6 to a -6. Remember, there is a difference between a subtraction sign and a negative sign. So we need to be clear for that. Now, step number 2 says just to model this. So I take that +2 and I draw 2 positive markers. Then for that -6, I draw 6 negative markers. Now remember, when you have one positive and one negative, they cancel out and give you 0. So we can show that just by highlighting one of the positives with one of the negatives and show that those are canceled out. Well, what does that leave us with at the end? We have more negatives. That means we receive -4 as our answer. So don't forget to make sure to cancel out a positive and a negative because they cancel out to 0. So +2 plus -6 is -4. I had more negatives than I had positives. Go ahead and hit pause and see if you can check for that understanding. Let's jump right back in. Keep, change, flip. We keep that 6 exactly the same. We change the subtraction to an addition, and we change that positive 2 to a negative 2. So now let's follow step number 2 and model it out. I have a positive 6, so that means I draw 6 positive markers. To that, I'm going to add 2 negatives. Now remember, a positive and a negative cancel out, and what am I left with here? I'm left with 4 positives. That positive and negative that cancels out, those cancel out to 0, so I don't have to worry about those. And here I have more positives than I have negatives. All right, let's jump down and try this one more time. Negative 13 minus negative 8. Well, let's write in our keep, change, flip first. We're going to keep that negative 13, change that minus sign to a plus sign or an addition sign, and change or flip that negative 8 to a positive 8. Now let's draw it out. We're going to draw 13 negatives. So here I have 7, 8, 9, 10, 11, 12, 13. And then I'm going to draw 8 positives. So 3, 4, 5, 6, 7, 8 positives. Now the same rules apply here. 1 positive and 1 negative will cancel out to 0. So I'm just using my highlighter to show that 1 positive matches with 1 negative, and those will be canceled out. We're going to essentially pretend like those are not there. What's left over when we're finished with those positives and negatives canceling out? Well, we're left with negative 5, or 5 negatives remaining. All right, go ahead and hit pause to check for understanding so that you can try this next problem on your own. Don't worry, I'm sure you can do it. There's just a few things that you need to remember. The first reminder that I want to share with you is that when you have a positive and you're adding to it a negative, or when you have a negative and you're adding to it a positive, it really just depends on who has more. That's how you're going to know what your answer is. It depends on the larger value. So if we looked at that negative 13, we have 13 negatives versus 8 positives. That means we have more negatives and our answer will be negative. So anytime you're adding 2 different signs, it depends on the larger value. All right, let's answer this check for understanding. We're going to start with step number 1, keep, change, flip. So keep that negative 7, change that subtraction to an addition, and change that negative 4 to a positive 4. So just looking at this, who has more? Do I have more negatives or more positives? Once I've drawn them out, as our step number 2 asks us to, we can see that there are more negatives than there are positives. So I'm going to zero out 1 negative and 1 positive, and what I have remaining is negative 3. Way to go. Great job. Let's try a few more. Do you remember the steps to solving how to subtract positive and negative integers using models? I'm sure you do. The first step is to keep, change, flip. So whenever we start this problem, you can immediately write that in because we prefer doing addition problems. So I'll keep that negative 8. I'll change my subtraction to an addition, and then I'll change that positive 14 to a negative 14. Now we can just draw out what we have. Negative 8 means there are 8 negative markers that I need to draw. Negative 14 means there are 14 negative markers that I need to draw. Now when I'm adding a negative and a negative, that just means my answer is going to be more negative. So negative 8 plus negative 14 is negative 22. Go ahead and hit pause and see if you can do this check for understanding. Negative 9 minus 1. All right, let's begin. Step 1, keep, change, flip. Keep that -9, change that negative sign, or excuse me, that minus sign to a plus sign, and change that +1 to a -1. Let's draw those out as in step number 2 asks us to, and we're going to draw 9 negatives for our first value and 1 negative for the second. That gives us a total of 10 negatives, so our answer is -10. Next problem up, 16 minus -5. We're going to jump right in with keep, change, flip. We keep our 16, change the subtraction to an addition, and flip that 5 from a negative to a positive. So now when we draw that out, the first thing we do is draw 16 positive markers. If you're working with pieces that you have at home, just pull out the ones that are designated as your positives and put those over to the side. Make sure you have 16 of those. And then I want you to add 5 more positives to those. So what does that give you? A total of 21 positives. Go ahead and hit pause and try to check for understanding. All right, let's do it. Keep, change, flip. That is step number 1. So we are going to keep -3. We are going to change that minus sign to an addition sign, and we're going to flip that -12 to a +12. Now here I'm dealing with two different signs. I have negatives and I have positives. Which one do I have more? Well, in this case, you can see once I draw them out that there are 12 positives. So there are more positives than there are negatives. I always remember that one negative and one positive cancel out and give me a value of 0. And what am I left with? 9 positives. So if you feel like you can subtract positive and negative integers using models, go ahead and check. Happy learning.
Welcome to KEP Curriculum. Let's discuss how to multiply integers.
Welcome, welcome. Let's begin by multiplying integers. Our expectation for this activity is to multiply positive integers on the number line. So how do we multiply positive integers at the number line? Well, step 1, the easiest way to begin is to begin at 0. Now that first value is going to give us information, and that's going to tell us the number of spaces that we need to move. So here we're working in increments of the first value. The second value is telling you how many times that you need to move that certain number of spaces, or how many jumps you need to make for that number of spaces. So let's dig into this. No need to worry about being confused. Let's go ahead and start here with the let's do it. Now the first one tells us that we're going to be jumping in increments of 8 spaces, and we need to do that 3 times. So if you look at the number line, my scale on the number line is 8, and I'm going from 0 to 8. That would count as one jump. 8 to 16 counts as a second jump, and 16 to 24 would count as my third jump. So in order for me to jump 8 spaces 3 times, I would land at a positive 24. All right, go ahead and hit pause, and I want you to try it and see if you can understand what we just did for that problem. All right, welcome back. How many times are we jumping? We're jumping 7 times, but what distance are we jumping? We're jumping a distance of 2. Does it matter if you choose whichever number first? It really doesn't. I just usually like to use the smaller number for my jumps. In this case, I did the opposite. So I jumped 2 spaces 7 times, and that landed at 14. Positive 2 times positive 7 is 14, and we've just shown that on the number line. Let's jump down to -6 times 6. Now in this situation, we're jumping -6, so that means we're jumping in the negative direction. 0 to -6 would be 6 spaces, and that would count as one jump. Because I want to jump 6 times, I'll just keep going in the negative direction 6 times until I get to negative 36. So a negative times a positive is a negative. Go ahead and pause and see if you can do this one and try this negative 5 times positive 4. What do you think that answer is going to be, positive or negative? Well, we're jumping 5 spaces in the negative direction, and we're going to do that 4 times. So negative 5 times positive 4 is negative 20. Hopefully this made a bunch of sense to you. If you feel like you can multiply positive integers on the number line, give it a check. Very, very good. Let's jump down now to multiplying negative integers on the number line. How would that look any different? Well, it really doesn't, because you can choose which number is your spacer and which number is your jumper. So for example, in this first problem, you see that the spacing that I'm using, the scale that I'm using, the increments that I'm using are based on 33. So here again, we're going to begin at 0, but we're jumping negative 33 spaces. And we're going to do that a total of 3 times. All right? When we multiply integers, I just want to give you guys a quick reminder that the same sign is positive, different signs are negative. So if I'm multiplying a positive and a negative, it's negative. If I'm multiplying a positive and a positive, my answer will be positive. If I'm multiplying a negative times a negative, my answer will be positive. So anytime they are the same, my answer is going to be positive. Back to our problem, 3 times negative 33, I have a positive and I have a negative. That means they are different. That means the answer that I'm going to get to this problem is going to be a negative answer, because 3 is positive and negative 33 is negative. All right? Remember, one of your numbers is the number of spaces that you're using, and usually I like to use the larger number for that. In this first case, it will be negative 33. And 3 is our smaller value, which usually I like to use the smaller value for jumps. Do you have to do it that way? Absolutely no. You can use spaces of 3 for this first problem and jump 33 times. That just seems like a lot for me, so I like to flip it and do it the other way. Okay? All right, so this time our spacer is going to be negative 33, and we're going to jump 3 times. So we start at 0. We jump negative 33, so that means we're jumping to the left 3 times. When we jump to the left 3 times, we land at negative 99. A positive times a negative is a negative, because those are different signs. So go ahead and hit that pause button and try this check for understanding, and let's see how you spaced it out. Now, when you're paying attention to this next problem, you'll notice that I have the number line there, and I used negative 102 as my increments on my number line, but you did not have to do that, and you could have used 6. Okay? All right, let's jump back into it. I'm using the spacer as negative 102, so I'm starting at 0, and I'm going to move 102 spaces in the negative direction, and then I'm going to do that 6 times. That's going to land me at negative 612. So here again, we're seeing a positive times a negative is going to give me a negative answer. All right, great job. Let's continue on. I have negative 55 times negative 3. This time, I'm working with 2 negative numbers. So that means my answer is going to be positive. Okay? Now, I am jumping 55 spaces, and you see I've marked that in the negative direction. But because now I'm multiplying that by a negative 3, I need to switch directions and jump from 0 55 spaces. Okay, so don't forget that it's always from 0. So a negative times a negative is a positive. Negative 55 times negative 3 is positive 165. Do not forget that. We have a negative times a negative. They are the same sign. That means my answer is positive. Okay? Great job. Go ahead and hit the pause button, and I want you to try this last check for understanding. Welcome back. My increments are going to be 21. My jumps are going to be 4. So I'm going to start off at 0. And remember, even though I went negative 21 in that direction, I had to about face for that negative 4. So negative times a negative is a positive. Negative 21 times negative 4 is a positive 84. Wonderful. If you feel like you can multiply integers on a number line, go ahead and check that box. And I look forward to hearing from you if you may need a little bit more assistance on this activity. I have tons of problems that we can practice. Don't worry. For this expectation, we are going to be multiplying positives and negative integers using models. Not on the number line this time. This time we're going to do it using models. And whenever we're using models, it's very important to remember that you want to draw these out as clearly as you can. Now, because I'm working on my computer, I can easily just clip them and duplicate them. And it may take you a little more effort when you're drawing the models out, but you can still manage it. I know you can do it. When we're doing these problems, we're still going to represent our models the same way we did before. So we're going to use the plus sign for our positive values, and we're going to use a minus symbol for our negative values. Now, I have stated here to use the first value versus the second value, but because this is multiplication, you can always switch those around. If you want the first value to go first and then the second value, that's okay. And if you want to go to the second value first and then go back to the first value, that's perfectly fine as well. These, I believe, will be done in order the way that we see them, just to make sure that you understand. All right, so the first thing that I'm going to do here is to draw 3, 4, 5, 6, 7, 8, 9 positives. Now, when I draw those 9 positives, I need to duplicate those 9 positives 4 times. So that's what you see me doing here. That's the second, that's the third, and that is the fourth. So if I took that 9 and I drew that 9 out 4 times, I would have a total of 36 positive pieces. And the way that I can show that is that whole first section is that 1, the second section is 2, third section 3, fourth section 4. So I've drawn 9 4 times to give me a value of 36. All of this is positive because they are the same sign. A positive times a positive is a positive. All right, go ahead and hit that pause button and let's see if you can handle this check for understanding, and I'll be right back. All right, welcome back. Let's draw 6 here. We're going to draw 6 positives, and then we're going to duplicate those 6 positives how many times? 3 times. Yes. So 6 times 3 means I draw the 6 and then I duplicate that, so I have a total of 3 sets of 6. And I just wanted to highlight that for you so that you can see a positive times a positive is a positive. 6 times 3 is 18. Perfect. Let's continue on and let's try some that are negative, because remember, if we start out with negative, but we're multiplying by negative, then something's going to change. Now, I've drawn out this negative 5 here, but how do I show it's a negative 7? Well, I'm going to make that negative 5 now a positive 5 because I need to switch it because of that negative 7. After I've changed that -5 to a +5, then I can just duplicate this 7 times in total. So I would have -5 that's been changed to +5, and then I've shown that 7 times. So essentially here I have a negative times a negative, which is a positive. -5 times -7 is +35. Wonderful. Go ahead and hit that pause button and try this check for understanding on your own. -8 times -8. You will definitely be able to solve this. I believe in you. All right, welcome back. Now, I started out showing this -8 and I immediately drew a positive, but I don't want to do that. I want to show you the right way to do this. We're going to start with our -8, so draw 8 negative symbols or 8 negative markers. And then because of this second -8, that is when I change those to the opposite of what they are. So I changed them from negatives to positives. So that now gives me 8 positive markers, and I need to show that 8 times. -8 times -8 is going to be a total value of 64. A negative times a negative is a positive. Remember, same signs are positive. Different signs are negative. So when we're multiplying integers, those are the rules you should not forget. Here, I'm just making sure that I have a total of 8 sections, and that's what you see me highlighting through here. Negative times a negative is a positive. Very, very good. If you have any questions about that, please make sure to leave a comment below and we can discuss it. Let's try 4 more problems before we decide whether or not we understand. So in order for us to do this, where do you want to start? Do you want to start drawing 3 positives or do you want to start drawing 11 negatives? You get that option. You don't have to do just 3 and then duplicate it 11 times. You can do -11 and then duplicate that 3 times. So that's really up to you. What I chose to do here was the -11. I like the bigger numbers there. And then just like with my number line, my jumps are the smaller numbers. So here I have -11. And I'm going to duplicate that 3 times. I do not need to change the sign because the 3 is positive. So 3 times -11, 1, 2, 3 rows of -11 is going to give me a total of -33. So I see here that a positive times a negative is a negative. When I have different signs, they are negative. So let's talk about the rules here. What steps did we do? Now, your steps may be a little bit different from mine because you chose to use the 3 as a positive, and that's perfectly okay. What we do is we model one value with the correct sign. And then we use that second value to decide how to duplicate it. So if it's a negative, we have to switch it and duplicate it. And if it's a positive, we can just duplicate it. So here in this instance, we had a +3, and that's why we just duplicated the -3 times. Okay? Go ahead and hit that pause button and let's see what you're thinking for the check for understanding. All right, welcome back. Here again, I'm doing this problem where I'm drawing the 10 negatives first, and then I'm going to duplicate that 10 how many times? 6 times. Yes, hopefully you got that. So I take that -10 and I just duplicate that 6 times. Here's 4, 5, and one more makes 6. So if I had 10 negatives and I had 10 negatives 6 times, that would give me a total of 60 negatives. 10 negatives grouped into 6 different groups would still give me a total of -60. So here again, we have a positive times a negative. Those are different. Positive times a negative. That means my answer will be negative. All right, let's jump down here to the bottom. Negative 5 times 8. Now, what are you guys thinking? Are you going to put negatives or positives? I'm putting negatives just for this one, just to show you something different. Okay, so I'm going to start here with this negative 5, and I'm going to just show that I'm going to duplicate it 8 times. So that is a 4 times there. And then I'm going to double that one, and that gives me a total of 8. So I took that negative 5 and I essentially wrote it out 8 different times. So negative 5, 1, 2, 3, 4, 5, 6, 7, 8. 8 times gives me negative 40. All right, a negative times a positive is a negative answer. So negative 5 times positive 8 is negative 40. Go ahead and try it on your own. I'm sure you could do it. All right, here, negative 21 times positive 2. So I'm going to use this negative 21, and I'm going to draw that out first because it would make no sense for me to draw 2 21 times when I can just draw 21 2 times. Hopefully that makes sense. So I drew out 21 negative markers, and then I copied it 2 times. So this is my first time. This is the second time. How many negatives do I have there in total? Well, I have a negative 42 there. I have 42 negatives there. Great job. If you feel like you can multiply positives and negatives integers using models, go ahead and give me a check.
Welcome to KEP Curriculum. Let's discuss how to divide integers.
Welcome, welcome. Let's dive right on in and talk about dividing integers. Our expectation for today's learning is to divide positive integers on the number line. Now, the way that I like to do this, of course, I like to start with showing what my values are on the number line and making sure that I have a proper scale. And then I move forward or backwards based on whether or not we're moving in the positive direction or we're moving in the negative direction. So we're always going to start with our dividend, and that is the number that is trying to be divided. Then we use the divisor as our scale, and that's the amount that we move to the left or to the right on our number line. All right, so go ahead and jot these steps down. Step number 1 is to begin at the dividend. Step number 2 is to move the number of spaces as the divisor. Okay, we always want to remember that we want to move toward 0. So that's going to be really helpful as we're working out these division problems. So let's look at this. If we have a number divided by another number, that first number is our dividend. That's usually what goes inside of our divisor bracket. The second number is called our divisor. And usually that number is on the outside of our dividing bracket. Okay, so please pay attention to that. Dividend goes in, divisor goes out the door. So one is inside, one is outside. Okay, let's do this. Let's see if we can do 36 divided by 12. 36 is our dividend. 12 is our divisor. So the first thing we do is begin at the dividend. Highlight that, and then we're going to move 12 units towards 0. So how are we getting to 0? We're going down 12 once, down 12 a second time, and down 12 a third time. So we had to move away from 36 towards 0 in increments of 12 3 times in order to reach 0. That means our answer here is 3. Go ahead and pause that and see if you can understand what happened here. Where do we start? We start at the dividend, which is 14. So we are going to highlight that on our number line and we're moving towards 0. Now, if we can only jump 2 at a time, how many jumps is it going to take us to get to 0? Well, here we can see 14 to 12 is 1, 12 to 10 is 2, and as we keep jumping, it took us a total of 7 jumps to make it from 14 down to 0 when we're jumping by 2s. All right? Hopefully that makes sense. Let's try another one as if we were looking from the negative integer or the negative side of the number line. The rules don't change. We still start at that negative 42 and we're still trying to jump towards 0. Now we're jumping in spaces of 3. So how many spaces can we jump to go from 42 to 0 if we can only jump 3 at a time? And that answer is negative 14. We jumped 14 spaces to get all the way back to 0. Very good. Hit that pause button and I want you to try this next one to jump from negative 27 down to 0 using increments of 9. My dividend is negative 27, so that's where I'm going to start. And then as I jump back to 0 using an increment of 9, I can see that it takes me 3 jumps to get back there. Negative 27 divided by positive 9 is a negative 3. I can divide positive integers on a number line. How about you? Let's continue with dividing negative integers on the number line this time. The rules do not change. We are still going to start with our dividend. We're going to move the amount of spaces as our divisor, and we are still going back towards 0. Okay, so the first one here, we're going to start at 64, and we want to jump 8 spaces at a time to get back to 0. How many spaces are we going to jump here? 3, 4, 5, 6, 7, 8. We jumped 8 spaces to get back to 0. So positive 64 divided by negative 8 is negative 8. Go ahead and hit pause and try to check this one for understanding. I highlighted the dividend for you, which is 96. So how do you want to move for the divisor? Well, the answer is that many units straight back to 0. How many 12s does it take to get from 96 to 0? (96) divided by negative 12 is negative 8. It took 8 spaces to get there. Moving on, we have negative 80 divided by negative 20. So we're still going to start at that negative 80, but we're trying to jump back to 0. Now remember, same signs. A negative divided by a negative is a positive. Same signs are positive. So it took me 4 jumps to get back to 0 using increments of 20. The answer is 4. Go ahead and hit pause and see if you can check for understanding. I've highlighted the dividend for you, which is negative 42. So the divisor is how many units you're using to move. So 42 to 39, that would be my first jump. How many jumps do I need to make to get all the way back to 0? Exactly, I need to make 14 jumps. I can divide negative integers on a number line. If you feel that you can divide negative integers on a number line as well, please make sure to check the box below. Now I'm going to write in just some reminders of what I did. Please make sure that you're writing in your how-to, exactly what you're going to do to be successful with this section. The key for me is same signs give me positive answers. That's how I always decide, is my answer going to be positive or negative? Different signs give negative answers. It's as simple as that. Happy learning! The expectation for this assignment is dividing positive and negative integers using models. So we're going to dive right in. How do we begin with this problem? When we see a number divided by another number, the first thing we do is to draw a model for the dividend. The dividend is the entire quantity that we are trying to divide up. Secondly, we're going to separate that dividend based on the number of parts that the divisor tells us to separate them into. So we're going to separate into groups by the divisor. Now remember, the dividend goes inside of your dividing bracket. The divisor is on the outside of your dividing bracket. All right, so when you have a number divided by another number, that first number represents your dividend, that second number represents your divisor. Some people remember first in, last out. So the first number goes inside, the last number goes outside. So let's try it with our problem here, 28 divided by 7. The first thing that we're going to do is to draw a model for the dividend, which is 28. So that means I'm going to draw 28 positive markers to represent that 28. "24, 25, 26, 27, 28. Now what we want to do is to take those 28 pieces and divide them into 7 separate groups. So you see, if I go horizontally across, I can show that there are 7 groups going horizontally. And I can number these groups just to make sure that there are 7 that I'm looking for. 3, 4, 5, 6, 7. Now we can see in each group has 4 positives. So 28 divided by 7 is a positive 4. Go ahead and hit that pause button and try the check for understanding to make sure that you are understanding what we're doing in this activity. All right, welcome back. The first thing that we are going to do is we're going to represent that dividend with the appropriate number of markers that we need. So because 36 is our first number, which is our dividend, then that means I need to draw out 36 positive markers. 36 is a positive number, so I'm showing that as a positive marker using the plus sign. Then I'm going to separate this 36 into 4 groups. Now I want to make sure that each group gets the same amount, and I want to separate this out. So I'm going to again go directly horizontal, because you see there I have drawn this out with 4 groups per row. And we can number this just to make sure. 1, 2, 3, and 4. How many are in each group? Positive 9 belong in each group. So 36 divided by 4 is a positive 9. Let's try our next problem. Our next problem is negative 22 divided by negative 11. So we start by drawing a model for the dividend, which would be our negative 22. Here I'm showing negative 22 marks. So I'm using the subtraction sign or a negative to show 22 pieces. And now,
because I want to group them by the divisor, I have to pay attention to that negative sign that's in front of the divisor. Whenever I see that, I have to change my marks to the opposite of what they were. So before they were all negative, now I need to flip them and change them all to positive before I can separate them out into 11 groups. Now that I've changed them to positives, let's mark those out. So this is 5, 6, 7, 8, 9, 10, 11 groups. And let's just number that just to make sure. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And now how many do we have in each group? We have 2 positives. So we write that as a positive 2. Now I want you to try that on this check for understanding. So go ahead and hit pause and try this one on your own before I show you how to work this one out. All right, welcome back. We're going to start with 24 negative pieces. And I kind of cheat a little bit because whenever I see that I'm dividing into 4 groups, I try to use 4 rows or 4 columns to draw out my 24 pieces. So because we're dividing by a -4, we have to use that negative to change all of our marks to the opposite. So all of the negatives that we have drawn for the -24, we now need to change those to a positive. Once you've changed all of those, we're going to figure out how many belong in each of the 4 groups. 1, 2, 3, 4. You see, I've highlighted 4 groups and I'm going to number those 1, 2, 3, 4. Now, how many is in each group? That answer is a positive 6. Great job. Let's continue on. So when we are working through division problems, please remember our first step is to model the dividend. We model the dividend using positive or negative markers depending on what our number is. And then we separate that dividend based on the divisor into groups. All right? Just a reminder for anyone who has forgotten. If you are dividing with the same sign, so for example, you have a positive divided by a positive, that's going to give you a positive answer. If you have a negative divided by a negative, that's also going to give you a positive answer because those signs are the same. If you're working with different signs, for example, one is positive and one is negative, then you will always get a negative answer. Starting with this problem here, 36 divided by -12 means that I start with my dividend and draw 36 positive markers. Once I have 36 positive markers, then I separate those 36 out into 12 groups. But before I do that, I need to look for that negative sign that's in front of 12 that tells me to change all of my markers to the opposite. So initially I had 36 positive. Because of that negative in front of the 12, that means turn all of these 36 positives into a negative marker. Once I've done that, then I can separate them out into 12 groups. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, let's number those just to make sure. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yes, I do have 12 groups. And how many belong in each group? Well, that answer is 3 negatives or -3. Go ahead and hit pause and try the check for understanding to make sure that you are understanding exactly what it is that we are doing with this problem. I'm sure you can do it. Let's start by drawing 60 positives. Now it's a little bit easier for me to do these because I can just copy and paste and duplicate. But if you are drawing these by hand, please make sure to take your time and show all 60 positive markers. Okay? So see here, now that I've drawn out 30, I can just duplicate this. But if you're working on your notebook, please draw them out. Now we're looking at that -3. So because that negative is standing in front of the 3, that means change all of my markers to the opposite. Because I had positive markers, I want to change them to negatives. Now, if I had negative markers, I would change them all to positives, just like I did in the previous problem. Notice how I'm using different colors here. It really helps to see if I draw all of my positives with one color and all my negatives with another color, it makes it really convenient. Now that I've done that, I'm going to separate these out into 3 groups. And I want you to notice that I can't just separate them out row by row as I did before, because in order for me to only get 3 groups, I have to use 2 of the rows per group. So 2 rows represent one group, 2 rows represent a second group, 2 rows represent the third group, and now how many are in each row? That answer is -20. All right, let's continue on. -25 divided by 5. So I'm going to write out all of my negatives there. And then I'm going to put them in 5 groups. 1, 2, 3, 4, and 5. How many is in each group? The answer is -5. Great job. Now go ahead and hit that pause and try this check for understanding. We start by drawing out 22 negative markers for our -22. And then we're going to separate that out into 2 groups. So like I said, usually I'll just kind of list them out one by one, knowing that I have 2 groups there, 1 and 2. So -22 divided by a +2 is -11. Great job. So if you can divide positive and negative integers using models, please go ahead and check. Happy learning. Welcome to KEP Curriculum. Let's discuss order of operations. Order of operations. The expectation for this lesson is to use order of operations to solve mathematical problems. So let's jump right in. What is the first step for the problem that we see? And here I've already put it in a box for you. It is 12 times 4. It is what is in parentheses. So the first step is to clear any of the parentheses or any of the brackets that we see. Now we know 12 times 4 is 48, so we can just write that information in. The second step when we're solving order of operation problems is to look at the exponents. We don't have any exponents in this problem. So here we can skip over step number 2 because there are no exponents there. Step number 3 for order of operations is to work any multiplication or division problems starting from the left, moving to the right. So the only problem that we see here on our second line is 18 divided by 3. That is a division problem, so we can solve that to give us 6. Please notice as we're working through these problems, we write the answer in and just drop everything else down. Step number 4 is to solve any addition or subtraction problems that you may have. And remember, you're always working from left to right. So here we have 48 plus 6 as our addition problem. And we can just work that down to get an answer of 54. Now let's go through and analyze this problem. We have an addition, a division, a multiplication, and a subtraction. According to our steps, what goes first? Well, hopefully you recognize that the division and the multiplication come before the addition and subtraction. But how do I know who to do first? Do I do the division first or do I do the multiplication first? Well, remember, when we're working on multiplication and division, we always work from left to right. So there are no parentheses, there are no exponents, and even though we say multiplication first, we do division first in this problem because it's on the left. After we do division, then we'll do multiplication, and then we can decide between our addition and subtraction. So here we still work from left to right, meaning we'll do the addition first and then the subtraction. So let's draw boxes or underline each step that we're going to do. The first thing we're going to do is 18 divided by 2. So that means we bring everything else down, the 14 and the plus sign. We work out 18 divided by 2, which is 9, and then we bring the remaining problem down. Now we decided that the second thing we were going to do was the multiplication portion. So let's go ahead and underline that so that we understand the next step in our problem, once we have solved the division, is to do multiplication. Whenever we're working out division and multiplication problems, please remember, we always work from left to right. All right? Now that 14 plus, we're still not going to touch that, so we're just going to drop that part straight down. Do not even bother it, just drop it straight down. 9 times 18 is the next portion of the problem that we would do, and that answer is 162. That minus 7 just drops right down. So what do we do third? Well, that would be the addition portion of this problem. So where do you see addition here? 14 plus 162. Once we solve that, that will give us 176, and we're just going to drop that minus 7 straight down. And our last portion of the problem that we need to do is subtraction. So 176 minus 7 is 169, and that would be the first bite of our pizza problem. All right, let's continue on. Here we have multiplication, addition, division, and another addition. So what do we do first? Well, we follow our order of operations. Do we have any parentheses? No, we don't need to worry about that. Do we have any exponents? No, we don't need to worry about that either. We do have multiplication, we do have division, and we have addition. So how do we know who goes first? Well, remember, on our line for multiplication and division, we can see that multiplication would be first because it's on the left. Division would be second. Now, even though we have two addition problems, we start with the one on the left first. So let's begin. Multiplication, 15 times 18 is 270. We bring everything else down. Plus 12 divided by 3 plus 9. Our second step is to do the division portion. So the division portion is 12 divided by 3. That means we'll bring everything else down. 270 plus 4. And let me change that color so that we understand where that 12 divided by 3 comes from. Change that to a red 4. And then we just bring that 9 simply down. So as we're doing addition here, remember we start on the left and we do 270 plus 4. 270 plus 4 is 274. And then we're going to bring that plus 9 straight down. Now our first bite of pizza is going to be the answer to this problem. So 274 plus 9 is 283. If that's the answer that you got, great job. Let's continue. Here we're going to write our PEMDAS again. PEMDAS. Do we have any parentheses? Well, yes, we do. And there's quite a bit of operations inside of our parentheses. We have an addition and a subtraction there. So even though we're working with the parentheses first, we have to do what's inside of the parentheses, which is the addition and subtraction. And because those two are on the same level, we still work from left to right. So that means we'll do the addition first and then the subtraction. That covers our parentheses. Then when we go to exponent, that would be problem number 3. Then multiplication and division, there is no multiplication here, so we're just going to do the division, and very lastly, the subtraction. So let's work this one out together. Please remember to bring everything down that you are not working with, all right? I love to switch colors. It's really super helpful. So first step is 9 plus 33. What is that answer? 9 plus 33 is 42. So we're going to write that in a different color, and then we're going to bring down all of the other information that we have using our same standard black that we started with. So we're going to bring down that minus 6, that divide by 6, that minus 3 squared. We're still working in parentheses, so we have to continue all of our parentheses before we move on. The next step would be 42 minus 6, which gives us a value of 36, and I bring everything else down, divide by 6, minus 3 squared. Now I can check off the parentheses. It's time for me to jump to exponents. Well, exponents just means to take that base and multiply it by the number of times the exponent says. So here, I know that answer is 9, but I want to write that in red and break it down a little bit further for you. 3 squared means to take that 3 and write it 2 times and then multiply it. So that's how we got 9. Next, we go back to our division. So 36 divided by 6 is 6, and we drop down that 9 that we did not touch. And our very last part of this problem, 6 minus 9, is negative 3. So if that's the answer you got, great job. Let's continue on. Parentheses, exponents, multiplication and division from left to right, addition and subtraction from left to right. So in our parentheses, we have a multiplication, we have an addition, and we have an exponent. How do we know who goes first? Because all of those are in our parentheses. Well, we just continue to walk down that PEMDAS stair step. So inside of my parentheses, the first thing that I should do is to take care of that exponent, even though it's there in the parentheses. Okay? The next thing that I would want to take care of, according to what follows exponents, would be my multiplication. And then very lastly, inside of my parentheses, I would take care of the addition. Once I'm finished with the parentheses, I can move on and take care of the additional multiplication and the addition problem at the very end. So let's go ahead and get started. Please remember to bring down everything you're not going to touch to begin with. So that 3 squared, that's what we're doing first. 3 squared just means 3 times 3, which is 9. Bring down your parentheses, bring down your plus 4. Awesome. What's the second one that we should do? Go ahead and underline it before I do. Yes, 9 times 5. Hopefully you were able to do that. And you see there are different ways to show multiplication. That's completely okay if you want to use the small x or if you want to use a dot, okay? 9 times 5 is 45. So then we're going to bring everything else down. Plus 9, close parenthesis, plus 4. The next step that we're going to do in this problem is the addition, 45 plus 9. So we bring down that 2. 45 plus 9 is 54, plus that 4 that we're going to bring down as well. And I need to change that 54 to red. My apologies, that's wrong. Let's continue on. 2 times 54 is 108. And I did write that one in the right color. And then I remembered to bring down that plus 4. So 108 plus 4 is 112. So the solution to this problem is 112, and that can be counted as our first step to this problem. So if you can use order of operations to solve mathematical problems, go ahead and give your notebook a check. Great job and happy learning. Welcome to Kept Curriculum. Let's discuss distributive property. Distributive property. The expectation for this lesson is to use distributive property to solve mathematical problems. So the first problem we have here is we have 3 lines of boys and 3 lines of girls. Now I'm going to use blue for boy because they both start with a B, and I'm going to use green for girl because they both start with a G. Now, if we had 3 lines of boys and 3 lines of girls, we can show it in this manner. We have 3 blue lines there and we have 3 green lines, and they can or don't have to be connected. They can or cannot. Now, if we say 3 lines of boys and girls, that means that they are all in one line together. So I would have blue attached to green in this way. So I can show that there are 3 lines of blue attached to 3 lines of green. Now, if I just had 3 lines of students, I would draw 3 lines. Now, basically, all of these 3 things say exactly the same thing because there are still girls and boys in this line and there are 3 lines. But what we want to do is practice breaking these down in different ways and showing the different ways that we can write this. So let's start at the beginning. I want to break down this 63. I know I'm going to have 5 of 63. So what does that mean? Well, that could mean that I have 5 times 60 plus 5 times 3. Because in order to get 63, I can break that down to the 1 space and the 10 space and give me 60 plus 3. So now that I put those in parentheses there, I remember to use the operation that I see, which is multiplication. And here I would have 5 times 60, and I like to show my multiplication with arrows, and then 5 times 3. So let's completely write that out to make sure that we understand. 5 times 60 plus 5 times 3. Now we like to do this because it's easier to do that mental math. We know how to do this. 5 times 60 would just be 5 times 6, and we add a 0 there, which is 300. And then we have 5 times 3, which is 15, and we'll combine those two together to give us 300 plus 15 for a total of 315. So distributive property is just a mental way to break down this problem and be able to work it out faster without having to use your calculator. Let's try this next problem. Do you want to break down the 4, or do you think it's more important to break down the 450? Oh, let's rewind real quick. 5 lines of 60 and 5 lines of 3. So we're adding those together. Now let's go to the 450. My apologies. How do you want to break that down? Well, we can break that down into dollars versus cents, right? I can say 6 times $4, and then I can also say 6 times 50 cents and just add those two together to give me a total of 6 times 450. So when they're together, we can separate them based on how we choose. As in the previous problem, we can separate them by ones and tens, or in this problem, we can separate them by dollars and cents. We're still multiplying that 6 to both of those. So 6 times 4 and 6 times 50 cents. But remember, we're adding that 4 and that 50 cents together, and that's why we're using the plus sign here. So 6 times 4 plus 6 times 50 cents. Perfect. Let's begin. What is 6 times 4? Come on, you know that answer. What is 6 times 4? Great job, 24. Now what is 6 times 50 cents? 3. Absolutely. So when we add the 24 and the 3 together, we get 27. It makes it super easy to work out these problems because we're using our mental math and we're making our problems much more visual and easy for us to see. So why do we decompose these problems? One is mental math, and two, it makes it easier. Here is our last problem for today. There are 50 people who are walking in a fundraising event. Each participant walks 5.3 miles. So how many miles are walked in total? Go ahead and hit pause and see if you can check this one out before we get started. Some things I would like for you to think about is which one do you want to break up? Do you want to break up the 50 or do you want to break up the 5.3? For me, I think it would be a lot easier to break down the miles to solve this problem in order to simplify, because I can say 50 times 5 and 50 times 0.3. So take that 5.3 and let's separate that out into two pieces that can be added together. And we're using the whole number and then the tenths place. So 5.3 can be broken down into 5 and 3/10. So I'm going to use that 50 and I'm going to multiply it by the 5. And then I'm going to use that 50 and multiply it by the 3/10 there. And I like to show my multiplication with arrows. So when you draw the arrows on there, that's the same thing as saying that you are multiplying. So let's write this one all the way out. 5 times 50 plus 5 times essentially 0.3 or 3/10 would give me 250 plus 15. So 5 times 50 is 250. 50 times 3/10 is 15, and we add those two together to get a grand total of 265. And that's how many total miles were walked by all 50 people. Great job on this activity. If you feel like you understand distributive property, go ahead and check your box off for this one. If not, feel free to watch the video again or send me a message and we can discuss it. Happy learning! Thank you for watching. Don't forget to like, comment, and subscribe.